pull up a little bit of data here. Titanic. I'm picking this one out because I don't think anybody picked it. Anybody's working with this one. First of all, it's a zip file, so that scares off half the people anyway. Here we go. Okay. Now, where did that go now? Okay. So here's our data file. First of all, it's a text file. Oh, that scared everybody away. Let's take a look at that text file. It's pretty nasty, right? It's kind of hard to read that and so on and so forth. So what I'm going to do is I'm going to import that into Excel so I can get a better look at it. I'm going to open Excel. Okay, this is my first look at this. I've seen this data before, but imagine this is my first look at this data. So it's hard for me to read that, but you know, text file, if it's tab delimited or comma delimited, separated by tabs or commas, it should load into Excel pretty easily. I'm going to say open, and I'm going to go to located. Let's see, Titanic. Oh, that's not. Okay, double click on it. And right now it says, let's say delimited, and delimited with, let's see, fixed with or delimited, I think it's delimited, starts, the data starts not at row 1. Okay, start and point, actually I'm going to leave it at row 1. I think it'll give me a chance to identify that as value labels or variable names. I'm going to say next. Well, it kind of recognized that it was tab delimited. So you see it's broken up into different tabs, right? So it looks like it's getting it there. And if it wasn't, it didn't come out well, you could say, oh, maybe it's comma delimited instead and turn that off. Well, that doesn't work. So I'm going to stick with tab delimited. So it seems to understand what's there. I'm going to go to next. And let's see. Data format is general. I'm going to say text. I'm going to tell it it's text data. And I'm going to say next again. Oh, I'm going to say finish, I guess. Finish. And it's going to import it into Excel. I'm going to blow this up and see what we have. Well, what do we have here? We have person's name, right? We don't really need that. I'm going to ditch that. I'm going to say edit, delete that whole column. They have their passenger class. They have first class, second class, and third class. Steerage, I think, is third class. I don't think it goes beyond that. And there are how many people are on this boat? There are 1,300 people on this boat. Probably maybe about 500 crew as well. Right? So under 2,000. Boat I was on last week had 6,000 people on it. Right? So, and it was at least 4 times the length of the Titanic. Right? So boats these days are much bigger. Titanic was not so Titanic by today's standards, right? So first, second, and third class, right? So the next column is age. And we don't have age for everybody, do we? Some of them were not available. We didn't know what their age was. The next column is their gender. And the third column is whether they survived or didn't survive. But we don't see survived or didn't survive. All we see is a number, 0 or 1. Now, how do we know what that number represents? Well, we got to go to another document that this came with, which was the code book. Okay, and the code book tells us, okay, let's keep that blow up. Code book tells us that the passenger class is first, second, or third. The age is in years. The gender is male or female. And survived is 1 equals yes and 0 equals no. And so 1, they survived, 0, they didn't survive. Okay, so I'm going to take a look at this data. I'm going to say to myself, There's a couple of things that might be interesting to look at here. How about this null hypothesis? That there's no association between gender and whether or not you survive. Okay, let's test that association. Okay? So in order to do that, I'm going to import this into SPSS. But you know, before I do that, I'm going to change this. I'm going to neaten this up just a little bit. I'm going to change this to just a 1. And I'm going to drag it down all the way down here. I'm just going to do it here because it's a little easier in Excel. Most of the databases, you're not going to have to do this, but it's kind of nice that in this case, you got to see me doing it. I'm going to change all those first classes to a 1. Okay, let's keep going. Let's keep going. Oh, there we go. And they're all now 1s. Okay, I'm going to change second class to a 2. And again, I'm going to do the same thing. How many people in first class? Must have been pretty expensive. Okay, so I'm going to change these all to a 2. Okay. And I'm going to change third class to a 3. I'm going to put 3 in there. And I'm going to, actually, a lot of people here. Actually, I'm going to click in there. I'm going to scroll down quickly. Hold down the shift key. I don't think that'll work. I think I have to go back and do it the hard way. Didn't like being used this way. There are easier ways to do this, but I'd have to remember what they are. Okay, notice the age is either NA or a number. So SPSS will typically, if you tell it it's a numerical variable, scalar variable, it will ignore any text entries. So I don't think I have to do anything with that. Male and female might be another story. Actually, I think I don't have to change that. I'm going to give it a try the way it is. I might have to change male to, say, one of those to 1 and the other to 2. Actually, I think that's probably going to work better. Okay, so I'm cleaning up my data here so that I can use it a little bit more efficiently in SPSS. Okay, we're getting there. Okay, I think we're close. Oh, there we go. Oops, those are all 3s. Missed this one. 3. Okay, now I'm going to go in here. I'm going to sort it by gender. SPSS is going to warn me, do I want to expand this out, not just sort the genders, because if I don't expand it out, it will sort my data. The correct gender won't be next to the correct person. So yeah, expand it, and then say sort by. We can get in here to change it. Say okay. By sex. Say okay. Okay, so now I'm gonna put down females as I'm gonna put them down as 0, and I'm gonna put males down as 1. Oops. Actually, I'm gonna do this an easier way. I'm gonna highlight them. Just click on the top. It's highlighted on the top. Hold down the shift key, and I'm gonna. Oh, I meant to go stop at female. Okay, and I'm going to tell it to fill down. And for the males, I'll do the same thing, 1. And then I'll go all the way to the end. Shift, hold it down, and say fill down. Okay, so I'm going to save this as an Excel file. Save as, and Titanic workbook. Either one, doesn't matter. Now it's saved. I'm going to close it because SPSS won't import a file that's already open in another program. So I'm going to go to SPSS now. And all I've done is tinker with my data to clean it up, make it a little easier for me to work with in SPSS. I'm going to go into, this is the reason why I thought that probably no one actually went in here and played with this thing. I don't see it because it's an Excel file. I'm going to click Excel. And there it is. Now I can see it as an Excel file. I'm going to import it. And it realizes that the first row is not data, it's the variable names. And now I'm set to work with it. Okay, so the first thing I need to do is I need to identify these variables. So the first variable is passenger class. I'm going to label that. So it's a little easier for someone reading this, the output, to interpret it. Age is fine. I'm going to leave that the way it is. Sex is fine. I'm going to call it gender instead. And survived. That sounds good to me. I'll leave that the way it is. Okay, so a passenger class, that's a nominal variable that's correctly identified. And what are the values? The value 1 means first class. The value 2 means second class. And the value 3 means steerage. Okay, so we've identified the values for SPSS to work with. So the next variable is age. That is a numerical variable. So I'm going to make sure that SPSS understands that that's a numerical variable. It's not string, it's numeric. And I'm going to make sure that it understands that and say scalar. So now it knows it as a numerical variable. It'll ignore any text that's in there. Okay, and gender is a nominal variable, and I have to tell it what those values mean for gender. And I think I said 0 is female, and 1 is male. And I'm going to say OK. And survived, yes or no, that's also a nominal variable, so I have to put in here. What did I say from the code book? 1 survived, 1 was survived, and 0 didn't survive. Was that it? 1 survived, and 2 did not survive. Okay. I'm going to go back to the data view. And in the data view, you can see all of these summarized here. Okay. Survived, I guess there was no data in there for that particular person there, and so on and so forth. So let's see, data. I can turn that on and off if you want to see the actual data, or if you want to see the how SPSS is interpreting the data, I can put value labels back on. Okay, so now, what was I interested in? Was there a difference in in whether or not you survived if you were male or female? What kind of variable is gender? Categorical. What kind of variable is survived or didn't survive? Categorical. So we have categorical variables. Let's create a crosstab table. So let's go to analyze, descriptive statistics. I'm sorry, compare means, and go down to chi-square. And I'm going to be looking at the, I got the wrong one. Analyze, compare means. I'm sorry, let's see, where am I? Not compare means. I'm looking for descriptive statistics crosstabs. Descriptive statistics crosstabs. now that I got that straight. And in the rows, I'm going to put the exposure, and the exposure is gender. I think gender had something to do with whether or not you would survive. And then in the column, I'll put the outcomes, survived or didn't survive. Okay, so I'm going to click in cells, and I'm going to ask it to just right now calculate the observed values. I'll click continue, and I'll click OK. Our output table comes up, and here are our observed values. Where is it? There it is. Okay, let's take a look at our observed values. Let's see, 154 and 308, 709 and 142. Let's look at percentages by rows. Analyze, descriptive statistics crosstabs. Okay, let's this time go into cells. Tell it, give us the percentages by rows. So I can see what percentage of males survive and what percentage of females survive. Okay, put that in. Let's see, females 33% survived, males 83% survived. I think somebody gave me a bump steer out there, right? I think we reversed the, let me go back in there and change that. Am I right? Okay, gender. Okay, female is 1. I think I have to remove it to do this. Male is 0. Female is 1. Okay, let me do that analysis again. Descriptive statistics crosstabs. I'll do it again. And it seems a little bit more likely here. If you were female, 83% of you'd survived. If you were males, only 33% of you survived. Sounds like a problem for the males, right? Yes. Hi. Oh, you live right here. Hi. I'll get to him on Thursday. We exchange dirt. That's what we do. Okay. So at any rate, so that's pretty interesting, right? That they had that there was the rate, a difference in the rate of survival males and females. Well, what's our null hypothesis here? Null hypothesis is there's no association between gender and survival, and our alternative hypothesis is there is an association. So let's analyze this. Analyze descriptive statistics. One of the analysis we can do is chi-square. So I'm going to crosstabs. This time I'm going to go into statistics. I'm going to ask it to calculate the chi-square value. I'm going to click continue and OK. And now, in addition to doing the crosstabs table, it calculates chi-square for us. And the Pearson's chi-square value, 1 degree of freedom, 2x2 table, 1 degree of freedom, is 332. Anybody remember what the critical value of chi-square is for 1 degree of freedom? It's like 3.8, right? We got 332. So I think we pretty much can reject the null hypothesis. And in fact, you can see that the p-value is less than 0.000. Right? So we can reject the null hypothesis. What other kind of tests can we do on this now that we're dealing with a 2x2 table? We can do relative risk and odds ratio, right? I can actually look here and get an idea for relative risk, because the risk of surviving if you're a male, probability of surviving if male is 33%, and for a female is 83%. So 33% over 83% looks like your likelihood of surviving is 1/3 as much if you're a male, or 3 times as much if you flip it over if you're a female. Okay, so let's actually calculate that. Analyze, descriptive statistics, crosstabs, and I'm going to go in here. And this time when I go into statistics, I'm also going to click off risk. And when I click off risk, it'll actually calculate the odds ratio and the relative risk for me. And here we go. And here's our chi-square again, but now here's our risk. So odds ratio for gender, male versus female, is 0.1, right? 10%. The odds are 1/10 as much that you'll survive if you're a male than if you are a female. What about relative risk? For relative risk, 40% is likely to survive if you're a male versus your risk of likelihood of surviving is 40% of your risk of not surviving. If you look at it from the point of view of relative risk versus odds ratio. Yeah, if we had flipped over the ones and twos for males and females, it would have been a little bit more convenient because then we would have had a number that was greater than 1. So you could say that the likelihood of survival was 3 times as great for females than as males. Might be a little nicer way to say it. But you could also just invert these numbers. Well, what do I need here in my confidence interval, in order for me to say that I can reject the null hypothesis that my odds ratio is equal to 1, that there is a difference in odds. What do I need to have this 95% confidence interval not include? 1, shouldn't include 1. So what is it? It's 0.077 and 0.13. And also for the relative risk, it's 0.35 and 0.45. So 1 is not in that range, 95% confidence interval. So I can say with less than 5% chance of being wrong that I can reject my null hypothesis that the odds ratio is equal to 1. In other words, there are a difference in odds for survival if you're male versus if you're female. Similarly, there is a difference in relative risk of not surviving if you're male versus female. Right, so you can use chi-square and you can use odds ratio because it's a 2x2 table. If it's not a 2x2 table, you can't do odds ratio. What else can I do with this data? I have numerical variable, I have age, right? What's the average? What do you think the average age of survivors is to people that didn't survive? What do you think of that? Let's take a look at that. What test would we use to compare the average age of people who survived to people who didn't survive? So a categorical variable, survived or didn't survive, and a numerical variable, right? Age, average age. So what test do I use when I have 2 groups like that? I use a t-test, right? Independent samples t-test. I'm going to go here, analyze. I'm going to go down to compare means, independent samples t-test, and I'm going to put the test variable, which is age, which is what we're finding the average of. Average age. Right? And I'm going to put whether the person survived or not into the grouping variable. Now it's going to want to know what the values are. I think it's 0 and 1. 0 and 1. And it will go ahead and calculate the means for me. Let's see what I get. I get a t-test, and the t-test tells me that the t-value oh, actually, what am I doing here? Did I do what I meant to do? Is there a difference in the average age of people who survived versus didn't survive? All right, let's see what we have here. Okay, let's see. 0 or survived. Oh, no, I think it was 1 and 2. Let me go back. Analyze. Descriptive statistics. Means. Independent samples t-test. I think it was 1 and 2. 1. Okay. Yeah. This works out better. Nope, it must have been 0, 1. It just somehow or other didn't pick up the. Well, you know, if something's wrong with the grouping. Male and female survived. 1. Oh, that should have been a 0. Well, 1 and 2. 2. Oh, because it should have been a 0, right? Okay, 0. Okay, now it should work. Analyze, compare means, independent samples t-test, and I forgot what I put in there. Did I put a 2 and a 1? Anybody remember? I think I did. 0 and 1 I put? Compare means. Okay, this time it should work. Yeah, if I put in the right number. Okay, and here's our t-test. Our t-test comes out to be 1.6585 with a p-value of 0.092. There's 9%, 2.092. My null hypothesis is that the mean age of survivors is equal to the mean age of people who didn't survive. My alternative hypothesis is that the two means are different. Right? When you think that people that survived were younger people, would be first on the boats and stuff like that. In fact, this data tells us, wait a second, 9%. I can't reject the null hypothesis. So there is not a statistically significant difference between the average age of survivors and non-survivors. How about males and females? Let's try that. Analyze descriptive statistics. Compare means, independent samples t-test. What about average age of males and females that were passengers? Now that one I think was 0.1. Okay, let's see if that works. Okay, and the t-score for that is 1.5. So I can't say that there's a statistically significant difference in the ages of males and females that are on this ship. So I failed to reject those two null hypotheses. My first null hypothesis, looking at the association between survival and what were we looking at again? Survival and gender, was it? What was that? Age. What was the first one we did? We did a chi-square first. Survival and gender. Yeah, there was a statistically significant difference there. Okay, but there isn't. We weren't able to reject the null hypothesis for the average age of females is equal to the average age of males. We weren't able to reject the null hypothesis for the average age of survivors is equal to the average age of people that didn't survive. Well, how about first class, second class, third class? Whether or not they survived or not. So now we're going to compare. How many means are we going to compare? We're going to compare mean age. We're going to compare two categorical variables. We're going to compare the class, first class, second class, third class, who survived and didn't survive, to see if there's an association between those. So let's give that a try. Analyze. Descriptive statistics crosstabs. And this time I'm going to be looking at, passenger class in the rows and survival in the columns. And statistics, we're already calculating, well, we're not going to calculate risk. I'll leave it there, but you'll see that it'll reject the idea of calculating risk. Okay, let's take a look at what our chi-square came out to be. Came out to be 172, right? 2 degrees of freedom, because now it's a 2 by 3 table. Okay, so that's 2 degrees of freedom. Of the first class passengers, 59% survived. Of the second class passengers, 42% survived. Of the steerage class passengers, only 19% survived, right? Unfortunately, we can't do an odds ratio there, but we can see the difference in the percentages. And the chi-square tells us that we can reject the null hypothesis that the means for the three, that there's no association between survival and what passenger class that you were in. Can't do odds ratio there. How about the average age of the passengers in the 3 classes? I'm thinking that first class is probably the oldest group. Right? So let's take a look at that. So what are we looking at there? What kind of variables are we looking at there? We're looking at passenger class, and we're looking at age, a categorical variable and a numerical variable. Except this time our categorical variable has 3 possible values instead of 2. So instead of using the t-test, we use analysis of variance. Okay, good. Analyze, compare means, one-way analysis of variance. And I'm going to put in our dependence list is going to be the age, the numerical variable. And in our factor list is going to be the passenger class. Okay, and I'm just going to run my analysis of variance first. My analysis of variance tells me that the F value is 87, and the probability of being wrong if I reject the null hypothesis is less than 0.000. So the analysis of variance is telling me that mu for first class is not equals mu2 for first, second class, mu for third class, that those means are not all equal. It's not telling me which ones are different. If two of them are different or if all three are different, right? Statistically different. So now that I've shown that analysis of variance tells me I can reject my null hypothesis that the three means are the same, now I can reject that null hypothesis, but now I can go ahead and do post hoc tests to try and determine which are different. So now that I've done that, first you got to get your analysis of variance and justify going to the post hoc tests, right, which we did. Now I'm going to go into analyze, see, compare means, analysis of variance. And now I'm going to go into post hoc, and I'm going to pick either Tukey most likely or Bonferroni. Okay, you can choose whichever one you want. No long story behind which what the differences are. Both of those are relatively conservative tests. I'm going to click OK. It's going to do the analysis of variance again. We get the same result, but this time it's going to compare each of the categories to the other in terms of the mean. So the first class versus second class, the mean difference is 11, and the probability that those two means are different, the probability I'd be wrong rejecting that null hypothesis is 0.000. And so is first class versus steerage. And so is second class versus first class, and second class versus steerage, 0.021. All of these are less than 0.05. So I can say that all of the mean ages are different. Okay, and let's see if I can see. I'm going to go to the descriptive statistics, analyze, descriptive statistics, descriptives. I should have gone into explore. Analyze, descriptive statistics, explore. Okay, and I'm going to look at the age, and I'm going to look at passenger class, and I'm going to ask it to calculate all the descriptives for me. Let's see what I wind up with. Okay, let's see what I wound up with. I wound up with the average age for first class was 39, almost 40. Second class was 28. And third class was an average age of 25. So youngest to oldest, right? And statistically significantly different. And the other thing that this gives me is a box plot where I can examine this side by side. So you can see there's a big difference in average mean age for first class versus the other two classes, but they're all significantly different. And the variability is much bigger. Oldest, youngest, an infant, to oldest, like 76 years old or something like that. Okay, so I was able to tease, I don't know, what did I do, about like 5 or 6 analyses out of this 4 pieces of data from Titanic. By the way, it's all real data. Right? So if you guys are interested, you know, taking a closer look at it or something like that, you can. Any questions? Okay. So what's important now? What's the takeaway here? Takeaway here is that in order to analyze the data that you to show what you want to demonstrate or correctly use the statistics to prove your point, you have to make sure you're using the right statistical test. Okay. You can't, in other words, if you want to open a screw, you don't want a hammer, right? Same deal. You want the right tool. So when you're working with your statistics, take a look at what kind of variables they are, and then make your mind up and say to yourself, well, what I need to apply here is chi-square, or chi-square Non's ratio, or a t-test, or a paired samples t-test, or a single sample t-test, or an analysis of variance, and then post hoc test, or a correlation, or regression. And so we gave you a whole toolbox here, right? We gave you like 8 tools, got a whole tool set like at Home Depot, right? So, but the problem is applying the right test at the right time. Okay, so if you have problems, I'm going to post like a time, like for an hour or two over the weekend, and maybe also Monday night, when you can get online with me and when I can review. If you email me or post on the discussions board, if you have a question about this database or what kind of test to do or something like that, you can email me and I'll either help you out live during that session or I'll respond to you or something like that. Okay, guys? So I'm sorry Levi couldn't be here for this, because he loves the end of the semester. He loves this part of this whole thing. But he's going through his treatments and stuff like that. So he's doing his work, but and hopefully I'll be teaching with him in the fall. But okay, so go home, do some good work, and come back next week.